Let's look at the next ones. So let's talk about inequalities with absolute values. Now these guys can get a little bit strange. So I want you to remember a few things. The absolute value of some function, oh, there's that u again, is less than a, means that u is between negative a and a. So we write it like this. So u between negative a and a. Here, and if it's less than or equal to, this is exclusive because it doesn't include negative a and a. This is the same thing, but inclusive. But if it's greater than, so if the distance, so I want you guys to really think about this. Absolute value is really a distance. So if I say that the distance between, say, this point and this point, u and a, I say the distance between u and a is less than, well, a number, any number. So I don't want u and a. U and x, let's say. And I say this distance is less than a. That means that these are either, and this is distance a. That means that they have to be closer together than a. So they have to be within a of x. And if I'm looking at something where I want it to be far away, if it's greater than, so here's x and here's u, and I say this distance is greater than a, and we can actually say this is 0, then this means that u must be either less than negative a or greater than a, because the distance has to be on the outsides. And we cannot make that into one inequality. It's always two inequalities. So let's talk about solving absolute value inequalities. So the first step to solving absolute value inequalities is create either the double inequality for less than or equal to, or two inequalities for greater than or equal to. So we have to create one of these. So let's start with this one. This is a less than or equal to. So the absolute value, and actually I shouldn't even say that. That's actually step 2. Step 1 is isolate the absolute value. So since this one's already isolated, we can make this now into a double inequality. So we know that that means the distance, maybe the distance between 2x and 2 has to be between negative 8 and 8. We don't care which way it goes, we just know that the distance has to be between them. So what does x have to be in order for that to happen? So we add 2 to all three, and then of course we just solve as we know how to solve a double inequality. Negative 6 is less than or equal to 2x is less than or equal to 10. Now we divide all three things by 2. Negative 3 is less than or equal to x is less than or equal to 5. And now let's look at this one. Remember, isolate the absolute value first. So the first thing I need to do is add 2 to both sides. So now I need to say, okay, I need to make this either a double inequality if it's less than or equal to. No, it's not. Or two inequalities. It's greater than. So I'm going to make this into two inequalities. I cannot make this into one inequality. That does not make sense. This does not make sense. I want you to look at that, and I want you to read that from left to right to yourself. Negative 7 is greater than x plus 8, which is greater than 7. For one thing, we have a problem. And, oops, I wrote that the wrong way. Well, no, I wrote that right. So we can't really say that, because if I cut out the middleman in the middle, so what if I cut out this? Then I'm saying that negative 7 is greater than 7. I can't do that. So that is wrong. It has to be two separate inequalities in order for it to work. So now I'm going to x, so now I can solve each one of these. X is greater than negative 1, or x is less than negative 15. And there's my answers on these two. And that is it for today.